and thank you for watching this video. This is a first series of many videos that I'm going to publish regarding the payment gateway demo that I have. So this is a fictional demo that is created based on a payment gateway scenario. So the whole demo actually, when it is installed, will be on the Red Hat OpenShift container platform. So by using the payment gateway demo installer, it will install all the necessary services and components. So mainly there are three projects that will be created in the first place. So there is a payment gateway main project, which is called PayGate, right? This is a default project name. Of course, you can change it using the demo installer. So PayGate project actually will contain all the main business application for the payment gateway demo. And there is another one, another project called PayGate Istio System. So PayGate Istio System is the project that will be hosting and contains all the key server component for Red Hat Service Mesh. Red Hat Service Mesh is Istio solution that is based on the open source community project called Maestra. Okay, and there is also another project which is called PayGate RH SSO. So this project will have the Red Hat single sign-on Red Hat SSO, which is based on the open source community project called Keycloak. So basically, Keycloak will provide the authentication services for payment gateway. Of course, Red Hat single sign-on includes many others feature and function, which I'm not going to cover here, right? So the service mesh basically will provide the Istio environment to protect the microservices component that I have in here to do load balancing, to apply many type of others rules that we are going to introduce more into the demo in the later time. So today, this demo, which at this current version, right, you mainly just using the service mesh to protect all the internal services, and mainly it just expose one domain name, right, for the user to be able to access to the customer UI. Okay, so whenever the user need to access to the customer UI, you has to go through the domain name that is exposed by the Red Hat Service Mesh. One is access to here. Red Hat single sign-on will intercept that communication, and then it will prompt the user to log in to before being granted the access to the customer UI. So in here, the demo is the use case is very simple, right? It mainly just provide a simple credit transfer in between accounts. So by default, when the demo is installed, there are two demo account created. One is called John, another one is Jenny, right? So for example, right, what happened is that if after you have successful login, access to the customer UI, so you want to perform a transaction. Let's say I'm logging as a John, and I want to transfer money to Jenny. So I can do it on this interface. I key in the account number for Jenny and key in enter the amount that I want to transfer from my account to Jenny account. So when I hit enter and submit, right, what it does is that the customer UI will actually call the credit service, which is Node.js microservices. It only does one thing, right? What it does is that it will immediately take that information, right? The information about the source account, the target account, and the credit transfer information, and you submit into the Red Hat MQ stream, right? So Red Hat MQ Stream is an a Kafka solution that is based on the open source project called StreamZ, right? Mainly for the OpenShift, right? So in here, right, what it does is that once the credit transfer information submitted into the credit topic, immediately credit service will actually respond back to the UI to say everything is done and fine, right? So the user will see credit submitted successfully. So what happened in the back end is that once the new messages appear or submitted into the credit topic, there's one event collaborator services which is in Spring Boot base. You actually listen to the credit topic and pick up whatever new messages that is coming in. And what it does is that internally it will do the necessary calculation and debit and credit and create a new JSON messages and send it to the account service. So account service is a simple service that will purely just do one thing, that is doing credit and debit or query to the account service MongoDB. So when event collaborator send a credit request to the account service with the target account, source account, and the credit amount, account service mainly will just call to the account service MongoDB and perform the necessary debit and credit on the source and the target and source account, right? So once at the same time when this is happening, event collaborator will actually call to the credit or submit a messages to the credit response topic. So in here, the messages that is sent by event collaborator is mainly is a JSON format information containing the history of the transaction, right? So it has the information such as what is the source account, what is the target account, what is the MongoDB ID for each of these account, and what is the balance before and after, and what is the credit amount. So this credit response will mainly keep the transaction history. And the MongoDB Kafka Connect in here, what it does is that it will listen to the changes or new messages in this topic and then pick up that information and connect to the credit response MongoDB and update that, right? So this is what it does. So basically, if I would want to know all the so-called credit transfer history or transaction history, this is the database that I'll go to. Okay, so that is what happens when you perform a so-called credit transfer or credit debit into using the customer UI, right? So on the customer UI, there is a very simple UI to show, such as like what is your account ID, what is your so-called account balance. So this information actually stored in two places, right? Which is account profile MongoDB. Account profile MongoDB keep the user account information, such as like what is the account username, what is the account ID, what is the so-called address, and so on. And account service MongoDB purely keep the account balance information. So in order for when I'm a user looking at this UI, I'll need to have a better or so-called common interface to be able to retrieve these two information, which probably in two different format and protocol, and being able to just call one API to do that. So this is where the customer service JBoss fields services that is coming in. This is JBoss field services that is basically based on a camel, Apache Camel. So what it does is that when the customer UI call the customer service to say, please get my account detail information, including my balance. So customer service will actually call to the account profile, and the account profile will just return a set of format information, and account service will return a different set of information. Customer service will merge that information and then return one single format via one single interface to the customer UI. So this is how the payment gateway demo looks like. So in there, you will actually notice there are also components such as a Prometheus and Grafana installed by the demo. So you basically all the component services or all the microservices that is running in here, including Kafka, will be able to be monitored by the Prometheus. Prometheus will actually capture or scrap all the metrics information from all the component inside this Paygate project. And the Grafana provide the UI to be able to look at the metrics information in a graphical way, right, in the dashboard. So okay, the other one is that in the Red Hat Service Mesh, there are quite a number of other components that is installed as well by the Red Hat OpenShift operator. So there are components such as like the Istio itself, right? Kali, Prometheus, Grafana, Jaeger, right? So Jaeger will provide the distributed messaging, message tracing, right, for all the component inside here, and the Kali will provide the UI on top of the Jaeger for all the communication in between all the microservices in here. So together with both Red Hat Service Mesh and also the OpenShift itself, right? So it actually provide quite a complete environment for whoever would like to actually run their microservices on a Istio platform, right? So so this is basically the whole demo will looks like. So watch out for the next episode, and thank you for watching. Bye bye.